Friends, in today's video I am going to show you how to convert an to 60 volt 50 hertz AC signal into 18.5 volt DC signal using using transformerless circuit. This is simple and AC conducting wire that meet our these components. Here for safety I had kept the switch off, and I am using this AC tester so that I don't receive any electrical shock. Always I use a tester to touch any live wire or neutral wire when it is switched on, and even I use this tester for working with live AC wire, AC conducting wire, even when the switch is kept close for my own safety. As we know, AC shock are more fatal than DC. This is a tool. Can I show you the value? This is a 105J 450 volt boost PF capacitor. With that, this is that capacitor. With that we have 1 mega ohms resistance, and the wattage of this is simply quarter watt resistance. With this condenser we have that resistance in parallel combination, and this is the live wire. This is the live wire that is connected to the parallel combination of resistance and capacitor. That is the LR parallel circuit, and electrical resonance are taking place at if we consider only this set, and electrical resonance is taking up in this set, and this is the output from this terminal goes to the bridgeway rectifier. Friends, those who had studied class 12 physics book, they all know what is a bridge wave rectifier. It is made up of diode, and the number of this diode is 4007, 1N4007, and considering the neutral AC wire, it goes straight away to the 1.5 ohms 3 watt resistance. That is the higher wattage. Friends, you can feel that it is much more bigger and thicker than the than this green color resistance, but don't think that this is of more higher than 1 mega ohms. It is simply 1.5 ohms resistance, but because of its wattage, its size is bigger, and it is again connected to the another AC input side of the what it is called bridge wave rectifier. Then the output terminal, this violet side is plus, that is the live DC wire, and this is the minus for the blue, that is the neutral DC wire. Here we get about 220 volt DC, but mostly there is no change in the voltage of the AC signal, but the current has been changed to and reduced to few milliampere scale. Then this output voltage is fed to this bigger capacitor. The value of this capacitor, I must be careful and make sure this capacitor is discharged. Friends, for discharging a charged capacitor, we have to simply short circuit the capacitor. This capacitor is now discharged as it is short circuited, and we get a little crackling sound, example that, like that. This is one. How can I show you the value? Both the capacitor are same. Yeah, this is 100 microfarad, that is MFD 160 volt. Same with this capacitor. 100 microfarad 160 volt. Friends, this capacitor, these two set of parallel combination of these two capacitor is used to bring down that 220 DC voltage into near about 18 volt DC. Friends, then going to the point here, here these two capacitor we can consider as DC, as a set of isolated set of capacitor that is used to bring down the DC voltage, high DC voltage to low workable DC voltage. And here actually I had used a Zener diode, but unfortunately it was this Zener diode is for 5.5 volt Zener, that is the breakdown voltage, but we get the output voltage at this two end near about 19.5, 18.5 or 20, like that. It depends on the supplied AC current, how much voltage we are getting from the AC source. And for the wrong value that I have chosen as Zener diode, the diode has been damaged and I had to remove it there. A couple of diode has been damaged, and now this diode is simply a poor voltage stabilizer and extra resistance. It has resistance about 150 ohms, and it allows one way current, and to some extent it is a voltage stabilizer. And I will just connect this type of, what to say, this type of LED strip. This is 12 volt DC LED strip to glow in this circuit, and to make it glow in AC to DC circuit. Friends, I will show you how does it work. As you can see, I has connected the LED in series just in parallel combination with this capacitor. Just the two terminal, what to keep parallel or series combination with this, just the terminals, that two terminals, that is the output red for the live wire and orange for the neutral, is connected to the terminals of the LED. And I have checked for safety, ignoring the color codings of the wire. I had checked using this digital multimeter, which is the live wire and which is the neutral wire. And friends, now I am going to switch on this switch on the switch. Friends, I don't know whether my circuit will work or not, but for my safety, say that the plug may burst from here. And I had kept the refrigerator of my room switch off, so that the refrigerator that has cost near about 50,000 don't get spoiled up and suffer much more bigger damage for creating this smaller circuit. And now I am switching it on with great safety, and fortunately there is no explosion in this switchboard. And straight away going to the bulb, I can see this bulb is brightly lit, and I am going to make this room darker for more understandable. Hence you can see this bulb is much more brighter. This even works on 12 volt DC, and the entire room is illuminated. Where I can see everything in my room. It works as if a small night lamp, but we can see the things. We can see things clearly. And now I am going to switch on the LED tube light again. So lights on, and I am going to switch it off. Again on, again off with great safety. Friends, there are some sort of problem with this switchboard. I had to screw it tight. The kind of screws are coming out from these switches. I had to repair this, and there is little sound of sparkling inside this switchboard, and my circuit is over. Friends, in my next video I am going to show you how to make this type of LED stripe. These two are the LED strips that I has made today only. These two even glows in this circuit. Now in my next video I am going to show you how does it work.